Assalamualaikum and welcome to the third lecture of DSP. In this lecture, we are going to discuss the definition of system first of all and the other contents. Systems, the process signals to create the other signals. For example, we give an input signal to the system and it gives output as another signal. It changes the input signal to the output signals according to its algorithms. Further contents of this lecture are types of systems, properties of systems, proof with examples, convolution and correlation, and applications of these properties of systems. First of all, the types of the systems. Serials or cascaded systems. Serial or cascaded systems are those in which two systems are connected in series with each other. We have example H1 and H2 are the both two systems and they are connected in series with each other. Parallel system are connected with each other in parallel, and in feedback system we have a feedback from output to the input. Output is the part is used to modify the input. Now discuss about some properties of the systems. Causal or non-causal systems, linear or non-linear system, in time variant and time invariant systems. Causal systems or non-causal systems. Causal systems tells us about the past and the present and which do not have the future inputs, but the non-causal systems have the future inputs and do not have the past or present inputs. Linear or non-linear systems. Linear or non-linear system, there are two types of linear non-linear system: additive and homogeneous are linear systems and others are non-linear systems. If the system verifies the properties of additive and homogeneous, then it is called a linear system, otherwise it is called a non-linear system. Here are some examples of linear and non-linear and other systems. First equation gives us a linear system as it is satisfies both the additive and homogeneous properties. Second system is a non-linear system. It is flops due to the constant values it has and it does not satisfy. Third system is a causal system. It is in present or past. Fourth system is has a future value, so it is non-causal system. Fifth is time invariant and sixth is time variant system. Now let's study about convolution and correlation. We have general equation of convolution as y of n is equal to summation from minus infinity to 0 x of k is equal to h of n minus k. We have a signal y of n which is equal to x of n and a sign of correlation then h of n. The process, now we have an example y of n is equal to x of n minus 2x n minus 1 plus 3x n minus 2. If we calculate the y of n manually, then we have a lot of calculations. Then if we can find h of n, we have these following series of numbers having h of n from minus 1 to 3 and y of minus 2 to y of 5. In convolution we have to flip one side of the signal. For example, here we flip the h of n signal and then we will slide it towards the other side to get and multiply it with x of n to get the output y of n. It is an example of this type of convolution. Correlation, in this we only slide the relation of signal with the other signal. Following are the applications of correlation. Correlation helps us in the detection of waveform in noise, in antipolar scheme, and in threshold detector. Cross correlation helps us in pattern detection, signal detector, weather forecasting, security system, and water traffic monitoring. Thank you. That's all for today.